Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry and differentiation. Now the question I've chosen to go through here is 2019 paper 1 question 8. In this question we're given a function that describes the revenue that an air conditioning company, an air conditioning manufacturer makes throughout the year. And we're told that T represents the number of weeks after July and that R of T represents the revenue that the company makes that week. We're asked to work out to the nearest euro what revenue would a company make when T is equal to 20 or 20 weeks after July. So in this case it just means that T is equal to 20. Basically it just means you're taking your original function and everywhere there's a T you're subbing in a 20. There's two things here. It said that it's in radians. It told me that this is given in radians, so you have to make sure your calculator is in radians. And I think a lot of students often get the wrong answer here because they forget to put these brackets in. If you don't put in the brackets around that, your calculator will get the cos of pi over 26 and then it will multiply that by 20. But you want your calculator to get the cos of all of this, so you have to put the bracket in. If you put that bracket in, you should get 20,658.51, and it asked me to give it to the nearest euro, so you round up to 20,659 euro. And that's your final answer for part A. Okay, for part B of this question, we're asked to find the two values of T within the first 52 weeks for which the company's revenue is 26,250. Now that's relatively straightforward. It basically means you just sub in 26,250 into your original function. And the minute you sub it in, you should realize that the only unknown you have is T, which means I'll be able to work it out. So step by step, I just wanted to try and isolate my T. The first thing I did here was subtract 37,500 from both sides. And when you do that, you end up with minus 11,250 is equal to this. Next thing I want to do is try and isolate the costs. So I divide both sides by 22,500. The left hand side becomes minus 11,250 divided by 22,500, which actually works out as minus a half. So up to this point, I know that the cost of this angle is equal to minus a half. Now, obviously, in order to get this angle on its own, I could just get cos inverse and work out my value. But it's at this stage that it's important you realize that we were asked for two answers. So think of your unit circle. There should be 2 times on the unit circle when the cos of an angle is equal to minus a half. So now this has become a trigonometry question. So I want to continue this on. We need to take our unit circle into account and we need to get 2 different values. Okay, now so going through the scripts with leave inserts who did it in 2019, a lot of them got one answer but couldn't get the second answer. The reason is because they didn't identify when you have cos of an angle is equal to minus a half, there's 2 answers. So the first thing you should do is try and work out your reference angle. So we can read it straight off our log tables, or you can use your calculator. If you get cos inverse of a half, you get pi over 3. Or if you read it off your log tables, you can see that the cos of an angle is equal to a half at pi over 3. Now, clearly in this case, the cos of this angle is negative. And I know that on my unit circle, cos is negative in the second quadrant and in the third quadrant. In order to get a value in the second quadrant, if you're dealing with degrees, you usually think you started here, you've gone to 180 degrees and you're going backwards. If you're dealing with radians, you think the same principle. You started here, you've gone to pi and you're going backwards. Remember, pi is equivalent to 180 degrees. So in this case, the second quadrant is pi minus my reference angle. So your first value there is 2 pi over 3. So I know that the angle, which was pi over 26 times t, is equal to 2 pi over 3. That's my first scenario. My second scenario is that it's in the third quadrant. If it's in the third quadrant, we started here, we went half of a revolution to pi, and you're going to continue on into the third quadrant. So it's pi plus pi over 3. In this case, working out is 4 pi over 3. So now we aren't at our answer yet, but at least we have 2 different scenarios. I know that pi over 26 times t is either 4 pi over 3 or 2 pi over 3, and now I can just continue on, isolate my t and get my 2 different answers. Okay, so it's very straightforward now. I know pi over 26 times t is equal to 2 pi over 3. One equation, one unknown, I can find the value of t. First thing I did was divide both sides by pi, so in other words that just eliminates my pi. and I can say that t over 26 is equal to 2/3. Then if I just multiply both sides by 26, 26 by 2 gives me 52 over 3. So your first answer is that the revenue is 26,250 after 52 over 3 weeks. The other scenario is basically identical, except in this case you're landed equal to 4 pi over 3, divide by pi, multiply by 26, and your second answer works out as 104 over 3 weeks. So your two answers there are 104 over 3 and 52 over 3. Okay, so for part C in this question, we're asked to get the derivative of R of t. Now you should realize, right, R of t, there's two different terms. The first thing you should identify is that the derivative of 37,500, it's just a number, so the derivative is 0. So it's irrelevant. The only thing I need to get the derivative of is this first term. Now there's a number of things we need to take into account. According to the log tables, the derivative, if you have y equals cos x, the derivative of cos x is minus sine x. So certainly I'm going to end up, the derivative of cos is minus sine. Okay, but it's obviously not quite that straightforward. One of the complications we need to take into account is that there's a number in front of the cos. There's 22,500 in front of the cos. So I always in my head would do an easy one to figure out what's going on here. If I asked you to get the derivative of 3 cos x, well, if there's a number in front of it, it doesn't really affect the question, but it still stays there. If I asked you to get the derivative of 3 cos x, the 3 is basically irrelevant, but it stays there. You keep the 3, and then the derivative of cos x is minus sine x. So that's what I would do if I was dealing with that. Now I know that if there's a number in front of the cos, I just rewrite the number. So 22,500, it's going to stay in my answer, but I'm not actually getting the derivative. I'm not manipulating it. Now my next complication is that it's not the cos of a variable. There's a number in front of the variable. So I need to do something with the pi over 26. So again, I think it's important to try and do a simple one. If I asked you to get the derivative of cos 3x, well, again, you have two things to take into account. The derivative of cos 3x is minus sine 3x. So it's minus sine of the angle. Stays the exact same. The other thing is we need to then multiply by the derivative of the angle. In other words, we would need to multiply by the derivative of 3x. The derivative of 3x is 3. Or in other words, it's just a number in front of the variable. So if I'm getting the derivative of cos 3x is minus sine 3x multiplied by 3. Based on that logic, it's relatively straightforward to differentiate this. The derivative of cos pi over 26 times t, well, the first thing, it becomes minus sine pi over 26 times t. So the cos becomes minus sine and the angle doesn't change. But then I need to multiply by the derivative of the angle. The derivative of 3x was just 3, so clearly the derivative of pi over 26 is just pi over 26 times t. The derivative of that is just pi over 26. So that's the differentiation part. In other words, I might have done that long-winded, but in other words, 37,500 is just 0. 22,500 stays the exact same. Cos of an angle becomes minus sine of the same angle, and then you multiply by the derivative of the angle. The derivative of pi over 26 times t is just pi over 26. Now obviously we can manipulate this a little bit. I can just write that in neater, and obviously we're going to use this again, so it'll be a lot easier if it's simpler. There's a minus there, so there's a minus here, I'll just stick it in front. 22,500 multiplied by pi over 26, that simplifies down to 11,250 pi divided by 13. If you just plug that into your calculator, it'll give you this. And I can write this bit as just the sine of pi times t over 26. And that's it, simplified as much as it possibly can be. So that's your answer to part C. Okay, in part D, we're asked to use calculus to show that the revenue is increasing 30 weeks after the beginning of July. Now, to use calculus, obviously they're talking about differentiation. You should realize that if the revenue is increasing, then that means that the slope of the function must be positive. If the slope is positive, imagine our function, it looks something like that. It's a trig graph, so it looks something like that. If the revenue is increasing, then obviously the slope of the graph must be increasing as well. If the slope is increasing, that means the revenue after 30 weeks is getting bigger. So in order to show that the revenue is increasing, that means the slope is positive. And remember that the first derivative of a function represents the slope. So basically what they're asking you to do is show that the first derivative is greater than 0 when t is equal to 30. So that's all. We just need to find or dash of 30. We've already worked out what the derivative is, or in other words what the slope is. All I need to do is sub 30 into my previous answer. When you sub 30 into your previous answer, it works out as 1263.44. Clearly that's greater than 0, so happy days, that means the revenue must be increasing. So that's all that we need for part D here. In part E, it asks me to find a value for t within the first 52 weeks when the revenue is at a minimum, and to use the second derivative in order to verify your answer. So first of all, you need to realize that if we're looking for a minimum, that means we're looking for the turning point of the graph. Remember, we talked about the shape of the graph in the last one. The shape of the graph is something like that. And I'm looking for the minimum point within the first 52 weeks. So in order to identify a turning point, that means that the slope is equal to 0. Where a graph turns, the slope is equal to 0. And another way of describing the slope is the derivative. So in other words, they're asking you to let the first derivative equal to 0 and find the value of t. So in this case, I could say that or dash t, my first derivative is that. And I'm going to let the whole first derivative equal to 0. Now I think just watch what I did on this line because it might confuse people. If 0 is equal to a number times the sine of another number, if it's equal to 0, then I can just say that the sine of the angle is equal to 0. I can just completely ignore the variable. Like for example, it's like I'm saying if 3x was equal to 0, the 3 is irrelevant. I can just say that x is also equal to 0. If 3 times x must be 0, then also I could say x is equal to 0. So if this number times the sine of an angle is equal to 0, then I can just ignore the number and say that the sine of this angle is equal to 0. Now again, we should find two different values here. Remember, the sine of an angle is equal to 0 in two different places. So we need to identify two different answers here. We need to go to our unit circle. Okay, so now we need to find the 2 times when the sine of an angle is equal to 0. Now, different rules apply in the unit circle if we're dealing with either 0 or 1. Okay, if it's either 0 or 1, that means that our answer lies on either the x-axis or the y-axis. Now you'll notice I've drawn this unit circle. It comes directly from page 13 in our log tables. In the log tables, it's really important that you notice they've labeled one point on the edge of the circle. This point, and they've called it the point cos A sine A. And that indicates to us that in the unit circle, the x value, the cos of an angle, is represented as the x value. The sine of an angle is represented as the y value. And that's the key to getting the 2 times when the sine of an angle is equal to 0. So I know that the sine of an angle on the unit circle is represented as the y value. In other words, I'm trying to find when is the y value in the unit circle equal to 0. Clearly the y value is equal to 0 when it lies on the x-axis. In other words, at 0 and at pi. Or if we were dealing with degrees, it would be at 0 degrees and at 180 degrees. But in this scenario, the 2 times on the unit circle when the y value is a 0 is at this point in the unit circle and at this point in the unit circle. So I can say the sine of this angle, the sine of the angle equals 0. The angle, it must be either 0 or it must be pi. So they're the two different answers. I can say that pi over 26 times t, it's either equal to 0 or else pi over 26 times t is equal to pi. So now I have two different scenarios and I can get my two different answers. So it's relatively straightforward now. I can say that pi over 26 times t equals 0, which means that t must be equal to 0. That's my first scenario. On the other hand, I could say pi over 26 times t is equal to pi. If you divide both sides by pi, then you end up with t over 26 is equal to 1, because remember the pi's aren't actually cancelling. We're dividing pi into pi and we're left with 1. We do the same here and it's just 1t over 26. So here what all I need to do is multiply both sides by 26, and my final answer there is t equals 26. Now remember, we were asked to find the minimum point. We haven't even dealt with that yet. We've just identified where the turning points are. So we know that a turning point exists when t equals 0, and a turning point exists when t is equal to 26. Now, in order to investigate which one is the maximum and which one is the minimum, we now need to get the second derivative. We already have the first derivative of the function, so now we need to differentiate it again. So we worked out previously the first derivative is minus 11,250 pi over 3 sine pi over 26 times t. Now this is going to be very similar to part C, so make sure you've watched my explanation for part C, because I'm going to go through it much faster. If I'm getting the derivative, the coefficient in front of sine, we can just rewrite that value. So we can just rewrite minus 11,250 pi over 3. We don't really have to do anything with it. According to the log tables, the derivative of sine of an angle is just cos of that angle. So this just becomes cos of 26 pi over 26 times t. But remember, if you're doing that, you also must multiply by the derivative of the angle. The derivative of pi over 26 times t is just pi over 26. So once we've worked this out, so that's our second derivative. Now I can investigate which one of my values from the previous, which one of my values t equals 0 or t equals 26 is a minimum. Remember that in order to do this, we're going to sub in our t values. So we're going to sub in t equals 0, and then we're going to sub in t equals 26. If when we sub in one of them, whichever one ends up, if I get the second derivative and it ends up being negative, that means it's a maximum point. So if I sub in one of these values into my second derivative and it's negative, that means it's a maximum point. And then on the other hand, if I sub in the other one and it works out greater than 0, that means it's a minimum point. So I'm just going to sub each of these in and investigate which one is the max, which one is the min. Okay, so we've worked out that there's a turning point when t is equal to 0 and there's a turning point when t is equal to 26. Now we've worked out the second derivative can be described as this. So in order to identify which is the max and which is the min, we simply sub in the t values of our turning points. So the first one was t equals 0. If you sub in t equals 0 into this, remember obviously your calculator still has to be in radians, it works out as minus 1,423.50. Clearly this is negative, so I can make a conclusion here. I can say, well, in this case, the second derivative is less than 0. If the second derivative is less than 0, that must be a maximum point. In other words, it's actually no good to us because the question asked us to identify the minimum point. So then rather than subbing in t equals 0, this time we're going to sub in 26. So just go back to this function and instead of a t, I put in a 26. And in that case, it works out as 1,423.50. So now we can conclude, well, happy days, that's clearly positive. So I can say that the second derivative at 26 is greater than 0. If it's greater than 0, that means it's a minimum point. In other words, that means that's the lowest revenue is after 26 weeks. The minimum point of this function that describes the revenue for the company is after 26 weeks. Now, I hope all of this video makes sense. If there's anything you're unsure of there or you'd like me to clarify something, just let me know in class or send me an email and I'll try and explain it a little bit differently.